In question 1, we've got the factory producing shoes and we've got 3 different types of defect, A, B, C, shown in the Venn diagram here out of a total of 120 shoes. Now we need to find the probability that the randomly selected shoe does not have defective soles. So defective soles is event C. So we don't want to be within C, so it could be 9, 0, 1, or 93 out of a total of 120. So we do 9 plus 0 plus 1 plus 93 divided by 120, which gives an answer of 103 over 120. In B, we need to find the probability of A intersection B intersection C dash. So we want to be in A, we want to be in B, but not in C. So it's the region here with the 0 because it's the common region between A and B, but not with C. And we can see that the answer is simply 0. In part C, we need to find the probability of A union B union C dash. So we want to be in A or in B or outside of C. So it's everything we have ticked. So it's everything but the 7 shoes that lie entirely within the only C region. So to find this probability, I will simply do 120, which is the total minus 7, over 120, which is of course 113 over 120. In part D, we need to find the probability that the shoe has at most one type of defect. So we certainly want the 9 that have only A defect, the 1 that has only B defect, and the 7 that has only C defect, as well as the 93 with no defects. So we will simply do 9 plus 1 plus 7 plus 93, and all of it over 120, and this gives an answer of 11 over 12. In E, we are told that given the selected shoe has at most one type of defect, what's the probability that it has defective stitching? So we know for sure it is conditional probability that we have at most one type of defect. So everything we have ticked here, and we are asking what's the probability that it has defective stitching. Well, defective stitching is event A, so it's this over what we have ticked. So I will be doing 9 over the 9 plus 1 plus 7 plus 93, which gives an answer of 9 over 110. And in part F, we are told that the random variable x is the number of the events A, B, C that occur, and we need to find the expectation of x. Well, this is the Venn diagram we had. So if we are counting the number of events that took place, then x can take values of 0, 1, 2, or 3, and we need to find the associated probabilities. So the probability of x is 0 is simply the 93 over 120. The probability that x is 1 is the 9 plus 1 plus 7 over 120. So we've got 9 plus 1 plus 7 over 120, which gives an answer of 17 over 120. Now for 2 events, it's the 0, the 3, and the 5. So 0 plus 3 plus 5 over 120, which gives an answer of 8 over 120. And finally, for 3 events, it's simply the intersection between A, B, and C. So this is 2 out of 120. And I can proceed to find the expectation of x by multiplying each value of x with its associated probability. So it's 0 times 93 over 120 plus 1 times the 17 over 120 plus 2 times the 8 over 120 plus 3 times 2 over 120, which gives an answer of 13 over 40. In question 2, Tom's car holds 50 liters of petrol when the tank is full, and we've got 10 journeys, each starting with 50 liters of petrol, and we're recording the distance traveled d kilometers and the amount of petrol used p liters. Here are the summary statistics, and we need to work out the product moment correlation coefficient between d and p. Well, let's start by reminding ourselves that the product moment correlation coefficient is given by SDP over the square root of SDD times SPP, Well, we've got SDD and SPP, and we need to find SDP, which is sigma dP minus sigma d times sigma p over n. Well, in our case, this is 5,240.8 minus 1,029 times 50.8 over 10, because we've got 10 observations, so n is 10. This gives an answer of 13.48, and therefore the product moment correlation coefficient is given by 13.48 over the square root of 344.9 times 0.576. We plug everything on the calculator and we get an answer of 0.956, correct to 3 significant figures. We are then told that the amount of petrol remaining in the fuel tank for each journey is W liters, and we need to write down an equation for W in terms of P. Well, we know that the fuel used and the fuel remaining together give me the tank capacity. So this means that P plus W is equal to 50, and therefore we've got that W is equal to 50 minus P. We are then told to write down the value of the product moment correlation coefficient between W and P, and I will actually start by considering what the graph of W against P would look like. So this is obviously going to be a straight line cutting the W axis at 50 and the P axis at 50. So we're looking at perfect linear correlation, because if I give you the value of P, then you immediately know exactly the value of W. There is no randomness here. We've got perfect negative linear correlation, and therefore R is -1. And then in part C, we need to write down the value of the PMCC between D and W. Well, in this question, we have seen 3 variables, P, W, and D. We have already found that the PMCC between P and D is 0.956, and between P and W is -1. So the product moment correlation coefficient between W and D will simply be 0.956 times -1, which is -0.956. In question 3, we've got a stem and leaf diagram showing the number of deliveries for 24 days. Now A, B, and C are positive integers, and we are told that an outlier is defined as any value greater than 1.5 times the interquartile range above the upper quartile. We are given that there is only one outlier for this data, and we need to show that C is 9. So to do that, I will start by finding the lower quartile Q1. So I'll do a quarter of the total observations, so a quarter of 24, which is 6. Now this is an integer, which means that Q1 is the midpoint of the 6th and the 7th observations. So I'll do 6th and 7th value over 2. Looking at the stem and leaf diagram, this is 116 plus 116 over 2, which is of course 116. I will proceed in finding Q3 in a similar way, so I'll be doing 3/4 of 24, which gives an answer of 18. So this time I'll be doing the midpoint of the 18th and 19th values, so 18th plus 19th over 2. So once more, looking at the stem and leaf diagram, both of them are 125. So this means that the upper quartile Q3 is 125, and therefore the interquartile range, which is Q3 minus Q1, is simply 125 minus 116, which is 9, which means that the boundary, the limit for outliers, is Q3 plus 1.5 times the interquartile range, which is 125 plus 1.5 times the 9. This turns out to be 138.5. So we know that any outlier should be greater than 138.5. And since we only have one outlier, it means that C is 9, so that the last observation, the greatest observation, is 139, and therefore we have that C is 9 as required. The number of deliveries is represented by D, and the data in the stem and leaf diagram has been coded according to X is D minus 125. These are the summary statistics for X, and we need to find the mean number of deliveries. Well, the mean of x is sigma x over n, which in our case is minus 96 over 24, which is negative 4. We know that x bar will be d bar minus 125, so minus 4 is d bar minus 125, which makes d bar to be 121. To find the standard deviation, I will start by stating that the standard deviation of x is simply the sum of the x minus x bar squared over n and all square root, which in our case is equal to 1306 over 24 and all square root, which gives an answer of 7.38. Well, since x is d minus 125, we know that deducting or adding a constant does not affect the spread, the variability, and therefore the standard deviation of x is equal to the standard deviation of d, which simply means that the standard deviation for d is 7.38. Now, one of these 24 days is selected at random, and the random variable capital D represents the number of deliveries, and the random variable capital X is defined to be D minus 125, and we need to determine the probability of D greater than 118 given that X is less than 0. So I will start by expressing this entirely in terms of D. So this is the probability of D being greater than 118 given that d minus 125 is less than 0, which is simply the probability of d greater than 118 given that d is less than 125. Now, looking at the stem and leaf diagram we were given, we know for sure that d is less than 125, so it could be any one of these values highlighted in red here, and we are asking what's the probability that d is greater than 118. So I've shown in blue those values that are greater than 118. We've got 1, 2, 3, 4, 5 values out of a total of 2 plus 11, 13 plus 1, 14. And therefore this means that the probability of d being greater than 118 given that x is less than 0 is simply 5 over 14. In question 4, the random variable w follows a discrete uniform distribution attaining values 1, 2, 3, 4, or 5, and all with the same probability, of course, of 1 over 5. We need to find the probability that w is greater than or equal to 2 and less than 3.5. Well, I will start by writing out the table of values for w, so the probability distribution of w, and we want the probability of 2 less than or equal to w less than 3.5. which is simply the probability of w being 2 or 3, which is of course 2 over 5. The discrete random variable x is 5 minus 2w, and we need to find the expectation of x. While looking at the distribution of w, we observe that by symmetry, the mean, the expectation of x, should be the middle value, the 3, and therefore we can proceed in saying that the expectation of x is simply the expectation of 5 minus 2w. So this is going to be 5 minus 2 times the expectation of w, which is 5 minus 2 times 3, which works out to be negative 1. To find the probability of x being less than w, I will start by substituting x with 5 minus 2w. So I've got an inequality entirely in terms of w. This is the probability of 5 less than 3w, which is the probability of 5 over 3 being less than w. Well, we know that 5 over 3 is 1.666 or 1.67. So we want the probability of w being greater than 1.67. This simply means that w could be 2, 3, 4, or 5. We've got 4 possible values out of a total of 5 values, all with the same probability. So this is simply 4 over 5. In D, we've got a new random variable capital Y defined to be 1 over capital W, and we need to find the probability distribution of Y and the variance of Y. So I will start by writing out the possible values for Y. So since W attains values 1, 2, 3, 4, 5, then Y attains values 1, 1 over 2, 1 over 3, 1 over 4, and 1 over 5, with corresponding probabilities being 1 over 5 throughout. So these are the 5 different values that y can attain, and I can proceed in finding the variance of y. To do that, I will start by finding the expectation of y. So it's going to be 1 times 1 over 5 plus a half times 1 over 5 plus a third times 1 over 5. So I'm multiplying each y value by the associated probability, plus a quarter times a fifth, plus a fifth times a fifth. So all of this is giving an answer of 137 over 300. And then I will proceed in finding the expectation of y squared. So it's going to be 1 squared times a fifth, plus a half squared times a fifth, plus a third squared times a fifth, plus a quarter squared times a fifth, plus a fifth squared times a fifth. Plug this everything on the calculator, get an answer of 5,269 over 18,000, and I can proceed in finding the variance of y. We know that the variance of y is simply the expectation of y squared minus the square of the expectation. So it's going to be 5,269 over 18,000 minus the 137 over 300 all squared. This gives an answer of 947 over 11,250. You can also give your answer as a decimal. It's 0.0842 to 3 significant figures. To find the variance of 2 minus 3y, remember that the 2 is not affecting the variability, it's just a constant. So the minus 3 is the only thing affecting the variance, and it will come out squared. So it's minus 3 squared variance of y, which is 9 times the 947 over 11,250. This gives an answer of 947 over 1,250, which as a decimal is 0.7576. In question 5, we've got a computer program randomly generating values from a normal distribution with parameters mean being 40 and standard deviation being 2.4, and we need to find the probability that the value generated will be less than 37. So x is the value and x follows normal with these parameters. The probability of x being less than 37, I will find this by standardizing first. So it's the probability of z being less than 37 minus the mean of 40 divided by the standard deviation of 2.4. This gives a value of z being less than minus 1.25. I want this to be positive, so I'll do 1 minus the probability of z being less than 1.25. Going to the table of values in the formula booklet for 1.25, I read off the probability of 0.8944. And therefore we've got 1 minus 0.8944, which is 0.1056. We then have that the mean has been changed to m, however the standard deviation remains as 2.4, and we've got 2 randomly generated independent values from this distribution, and the probability that both of these are greater than 32 is 0.16, and we need to find the value of m to 2 decimal places. So we now have that x follows normal with mean m and standard deviation 2.4, and we've got the probability of both of these values being greater than 32, so this will be squared because they are independent, is 0.16, which means that the probability of x being greater than 32 is the square root of 0.16, which gives an answer of 0.4. I will proceed by standardizing, so I've got the probability of z greater than 32 minus m over 2.4 being equal to 0.4. And going to the small table of values for the normal distribution for 0.4, the corresponding z value is 0.2533, which means that 32 minus m over 2.4 is equal to 0.2533. I will cross multiply to get 32 minus m is 0.60792, and therefore we get that 31.4 is the value of m. We now have that the mean has been changed to 4 and the standard deviation to 8, and we randomly generate 5 independent values from this distribution, and we need to determine the probability that at least one of these values is negative. So we've got that x follows normal 4h squared, and we are after the probability of at least one being negative, which is simply 1 minus all of them being positive. So I will start by finding the probability that one of them is positive. So the probability of x is 0 is the probability of z being greater than 0 minus 4 over 8, which is the probability of z being greater than minus 0.5. I will write this as the probability of z being less than 0.5. So going to my table of values for 0.5, the corresponding probability, as you can see, is 0.6915. So we have found the probability of one observation being greater than 0 to be 0.6915, and therefore the probability that at least one of them is negative will be 1 minus the probability of all 5 of them to be positive, and all 5 of them will be positive if I do 0.6915 to the power of 5, because they are independent, and therefore I can multiply the probabilities together, and this gives an answer of 0.842. In question 6, we've got students on a psychology course given a pre-test at the start of the course and a final exam at the end of the course. We've got a teacher recording the pre-test and the final exam results for 34 students, and we've got the least squares regression line shown here. Now for these students, the mean number of marks on the pre-test was 62.4, and we need to use the regression line to determine the mean number of marks for the final exam. Well, we know that the calculated regression line satisfies that f bar is 10.8 plus 0.748 times p bar, and we do have p bar, so f bar is going to be 10.8 plus 0.748 times the 62.4, the mean pre-test mark. So we get that f bar is 57.4752, which correct to 3 significant figures is 57.5. In part B, we need to give an interpretation of the gradient of the regression line of the 0.748, and we know that the gradient of a straight line represents the increase in y for every unit increase in x. We need to give our interpretation in context, so this means that for every extra mark on the pretest, the average mark on the final exam increases by 0.748. Now, considering the equation of the regression line, Priya says that she would expect someone who scored 0 marks on the pre-test score to score 10.8 marks on the final exam, and we need to comment on the reliability of this statement. So essentially, she's predicting the final exam score for someone who scored 0 marks. However, as you can see on our scatter plot here, we have nobody who scored less than 20. And therefore, we can simply say that since 0 lies outside the range of observed data, this statement is not reliable. In part D, we need to write down the number of marks achieved on the final exam for the student who exceeded the expectation of the regression model by the largest number of marks. So the straight line here is predicting, given P, what we expect to get for F, and we want someone who is significantly above the straight line. Obviously, this is the point circled here in red, and it's the person who scored 76 on their final exam. In E, we need to find the range of values of P for which the regression model predicts a greater number of marks on the final exam than on the pretest. So essentially, we need to solve F being greater than P. Now, F is 10.8 plus 0.748 P, and this is greater than P, which means that 10.8 is greater than 0.252 P, which means that 42.9 is greater than P. The teacher later discovers an error in the recorded data, and someone who achieved a score of 98 on the pre-test actually scored 92 and not 29 on the final exam. We've got the original summary statistics here, and we need to calculate the gradient of the new regression line. So essentially, I need to consider which summary statistics are being affected so I can recalculate the gradient. I will start by finding the new sum of PF, which is the previous sum of PF, the 133,486, minus the mistake, which was the 98 times 29, plus the correct one, which is 98 times 92, and this gives an answer of 131,660. Now we have already found from part A that F bar is 57.4752, and this means that the sigma F was 57.4752 times n, which was 34. This gives an answer of 1,954, and therefore the correct sigma F will be the 1,954 minus the mistake of 29 plus the correct of 92, which is 2017. I will proceed in finding the new SPF, which is the sigma PF minus the sigma P times the sigma F over the N. So in our case, it's 139,660 minus the 2,120 times 2017 over the N, which was 34, which gives an answer of 13,894.11 ... We know that the gradient is simply the SPF over the SPP, so SPF over SPP, and we've got both of these values. It's 13,894.11 ... over 15,573.76. This gives an answer of 0.892. However, the examiner here is accepting anything which rounds to 0.9. In question 7, we've got a bag containing n marbles, 7 of which are green. Now we will be drawing 3 marbles at random, and x represents the number of green marbles selected. This is the cumulative distribution function for the random variable x, and we need to show that this leads to n times n minus 1 times n minus 2 is 7,980. So let me start by observing that the probability of x being 3 is simply the difference between 37 over 38 and 1, because it's the cumulative distribution function. So to go from x is less than or equal to 2 up to x is less than or equal to 3, we only have the additional contribution of x is 3. So this is 1 minus 37 over 38, which is 1 over 38. Now the probability of drawing 3 green marbles is 7 over n for the first one, times 6 over n minus 1, because we've drawn 1 out, so we've got 6 green marbles out of a total of n minus 1 marbles, times 5 over n minus 2, and this should be equal to 1 over 38. This leads to 210 over n times n minus 1 times n minus 2 is equal to 1 over 38, and if I cross multiply, I get 7,980 is n times n minus 1 times n minus 2, which matches exactly the answer given in the question. We are then asked to verify that n is 21 satisfies the given equation. So if n is 21, I will substitute. I have 21 times 21 minus 1 times 21 minus 2, which gives an answer of 7,980, and therefore we conclude that n is 21 verifies the equation. In part C, we are told to use n is 21 to find the exact value of A and the exact value of B. So the way of approaching this question, notice it carries 6 marks. It's a big part. I will draw a tree diagram to see exactly what's happening. So we're drawing 3 times, so each time it could be a green or no green. We start with a total of 7 greens out of 21 in total. So 7 out of 21 of being green, 14 out of 21 of not being a green. Now, if the first one was a green, we are left with 6 out of 20. So this is 14 out of 20. And if the first 2 were green, then we're left with 5 out of 19 and 14 out of 19. Now, if I got a green and then no green, it means for the third row, I've got 6 out of 19 for being a green and 13 out of 19 for not a green. Now if I started with a no green, then it's 7 over 20 for a green here and 13 over 20 for no green. And for the third time, if I started with no green and then a green, then it's 6 over 19 and 13 over 19. Whereas for the last branch, it's going to be 7 over 19 and 12 over 19. And we need to find the exact value of A and B. So to do that, I will start by finding the probability of x is 0. Now the probability of x is 0 is simply the probability of drawing no greens. So it's the last branch here. This x is 0. Remember, we are counting the number of greens. So here we've got x is 1, x is 1, x is 2, x is 1, x is 2, x is 2, and x is 3. So for x is 0, I will simply do 14 over 21 times 13 over 20 times 12 over 19. Remember, I'm multiplying the probabilities of the branches through which I travel. So this gives me 26 over 95, and therefore we conclude that A is 26 over 95 because f of 0, the cumulative distribution, so probability of x less than or equal to 0 is simply the probability of x is 0, and we had that this was A in the given table, so A is 26 over 95. I will now proceed to find the probability of x is 1, which can be attained through green, no green, no green, or no green, green, no green, or no green, no green, and green. So there are three possibilities here. So the probability of x being equal to 1 is 7 over 21 times 14 over 20 times 13 over 19 plus the 14 over 21 times the 7 over 20 times the 13 over 19 plus 14 over 21 times the 13 over 20 times the 7 over 19, and this gives an answer of 91 over 190. Now remember that B was capital F of 1, which is the probability of x being less than or equal to 1, which is simply the probability of x is 0 plus the probability of x is 1. We have found that the probability of x is 0 is 26 over 95. The probability of x is 1 is 91 over 190, and this gives an answer of 143 over 190, which is the value of B.